Hey guys, welcome back. We are now going to talk about factoring, and we're going to talk about factoring a quadratic function. Okay, what a quadratic function is, it's basically the function in the form of y is equal to ax squared plus bx plus c. So this is in standard form for a quadratic function. And if we graph this, a quadratic function, we will get a parabola shape, not a line shape, but a parabola. What a parabola is a curve, okay, so we can either have it coming down or going up, and it's typically, it can go through the x-axis twice, okay, or we could have a situation where it actually never touches the x-axis, okay, or we could have a situation where it actually touches the x-axis just in one place, something like this. Okay, so each one of these will identify eventually the solutions, and the solution is actually where the graph crosses the x-axis, and you may hear it referred to as the roots, and you will hear it that way. But before we get into all this, we're actually going to talk about how we factor this quadratic function. So keep in mind it's in the form of ax squared plus bx plus c, where a and b are the coefficients and then c is the constant. Okay, so looking at the notes, the first thing we want to do is actually we start out and we factor out the greatest common factor like we did in the last video. So the first thing we do, we want to make sure is that the trinomial, the quadratic function, has the greatest common factor factored out. Also, we want to make sure that our leading coefficient is positive. The a has to be positive for this to work. So this is a method that's used to kind of help you factor. We call it complete the sum and product x. So just like we did before, only the product is going to be the a times the c. So you're going to take your a times your c, and then you're going to put it in the top of the x. The bottom of the x is going to be your b term, and this is going to be your b term. Okay, so now you're going to look for two numbers, m and n, that when multiplied together give you a times c, but when added together give you that middle term, or b. Okay, the second step you're going to do is actually then divide both the m and the n by the leading coefficient a. Okay, and many times the leading coefficient is 1, and it seems redundant, why are we dividing by 1? But it will make sense once you have a leading coefficient that is not 1. So if you are in the situation where m divided by a and n divided by a, don't divide into whole numbers or simplify into whole numbers. Make sure you simplify the fraction first, okay? And then I'm going to explain what we do with examples, because honestly this page is a little confusing, but you can refer back to it in your notes I want to try to show you how to do it with some examples, okay? So and then keep in mind too, if the polynomial can't be factored, it is considered prime. So it is a prime polynomial if it can't be factored, and we'll show you an example of that as well. So in this first example, I'm going to start out and I'm going to use the x method, okay? Because it's in standard form, it's in the form of ax squared plus bx plus c. Okay, I'm going to identify my a, my b, and my c. My a is going to be the coefficient of x squared, which is 1. My b is going to be 8, and my c is going to be 15. Okay, with the x method, we take a times c and we place it up at the top, and then our b is down at the bottom. So I'll do that just for the first one. Okay, so with numbers, a times c would be 15, and then the 8 would be the bottom. Okay, now we're going to use what we did in the last video and come up with two numbers that when multiplied together equal 15 and added together equal 8. Well, that would be 5 and 3, or you could do 3 and 5. Okay, now this is important. You're always going to take these two numbers and divide by the leading coefficient. Now, like I said, a lot of times it's 1, so it seems redundant. But here we've got a 5 and a 3. That means that when we factor this, okay, kind of doing a reverse kind of FOIL, we're going to say that our factors are actually, look at the variable, and the variable is x plus 5, because that's a positive 5, and then x plus 3. So we just factored it out. And if you notice, if you FOILed it, you would get x squared plus 3x plus 5x plus 15. And then that would be x squared plus 8x plus 15. So we kind of went backwards, all right? So we actually took this trinomial and we factored it. All right, looking at number 2, if I make my x, okay, 12 times 1, my a is 1, my c is 12, so the 12 is going to go up top, 7 down at the bottom. I'm going to think of two numbers that when multiplied together equal 12 and added together equals 7. And I could use, let's see, 3 and 4. Okay, I'm going to divide by the leading coefficient and simplify, so I get 4 and 3. So when I factor this, my variable is y, so it's going to be y plus 3 times y plus 4. And that would be my answer. And I can always check it by FOILing. So y times y is y squared. My outer is 4y, inner 3y, so that becomes 7y, and then 3 times 4 is 12. Okay, so I'm going to go ahead and try some more. Okay, my a here is 1, my c is negative 12, so 1 times negative 12 is negative 12, and my coefficient b is going to be 1. Okay, so I need two numbers that when added together, that when multiplied together equal negative 12 and add up to 1. I'm going to think of numbers close together, so I'm going to think of 4 and 3. I need it to be negative, so I need this to be positive. So in this case, the 3 is going to be negative. 4 times negative 3 is negative 12. 4 plus a negative 3 is positive 1. So be careful of your signs. Again, I'm dividing both sides by the leading coefficient. So I got a negative 3 and a 4. So then when I factor, it's q plus 4 times q minus 3. That would be my answer. And notice if I FOIL it, I would get the same answer. Okay, so number 4, I've got a 22 up top and a negative 13 down here. So I'm going to use my factors of 22. I'm going to think of 2 and 11. Okay, so 2 and 11 multiplied together, we get 22, but we've got to get a negative 2 and a negative 11 so that when added together it equals a negative 13. So you can actually do this without the x method. Eventually you'll be going to that where you'll start out and you'll say, well, I know that I can get x squared by saying x times x. Well, what two numbers can I multiply to get 22? 11 and 2. But I need my middle term to be negative 13, so I'm going to do a negative and a negative. Okay, or I can follow the x method. And don't forget, I actually divided here by 1 as well. So that's what we got for my answer. Okay, I'm going to have you guys try a few of these, but before we do that, number 5 is a little different. So notice we start out and see that negative leading coefficient. The first thing you always want to do is factor out a leading negative. Okay, so that's going to change your A, your B, and your C. And you're going to use the A, B, and C from what's in the parentheses because that's what you're going to be factoring. So when you do that, you've got 22 and a negative 10 here. So with 22, you could say, you can say 2 times, let's see, 2, oh, I'm sorry, saying why is that not working because it's 21. Okay, so that should be 21 right there. Okay, so we've got 21 here, and then we've got a negative 10. So for that, we can use a negative 7 and a negative 3. And then divide by 1, which is the leading coefficient, so we still end up with negative 7 and negative 3. So when we write this out, the leading negative has to come down times x minus 7, x minus 3. Okay, that would be our solution. So I want you guys to try 6, 7, and 8, and then come back and check your answers. So you really should be pausing the video right here, and I will put the answers on the screen, and then you can compare them. Okay, so pause right here. All right, so number 6, you should have gotten n minus 9 times n minus 1. Number 7 is actually an example of once you do this, you've got 3 and you've got 1. Well, there's no two numbers that you can multiply to get 3 that will add up to 9. And I should have given you guys this example if you got stuck. So this would be an example of a prime. Okay, so prime polynomial. All right, if I look at number 8, we should have done m minus 8 times m plus 7. Okay, and remember that multiplication is commutative, so it doesn't matter the order. So you could have had m plus 7 times m minus 8. They're both the same thing. Okay. Okay, so moving on. Now number 9, okay, number 9 is a little bit different because we have a leading coefficient of 2. So I want to be careful here because I'm going to show this to you. All right, so you're going to take 2 times negative 15 and you're going to get negative 30. So negative 30 goes up top. Down at the bottom you have a 7. You're going to think of the two numbers that you multiply to get negative 30 that add up to 7. You can use 10 and negative 3. Now here you're dividing by the leading coefficient and you're simplifying. So 10 halves is 5, but negative 3 halves can't be simplified. You're going to leave it as an improper fraction. Okay, so one of the factors is going to be w plus 5. Now this is where it gets a little tricky. The fraction piece, the denominator actually comes up and becomes the coefficient. So it's 2w minus 3. The numerator is then the constant. So if you notice, if you FOIL it, and this is where the little x method comes in handy, 2w times w is 2w squared. Okay, your outer would be negative 3w, your inner would be plus 10w, so that's a plus 7w, and then your last would be 5 times negative 3, which is negative 15. Okay, so with number 10, again, 3 times 2 is 6, and then we have a 5. Okay, the two numbers we multiply to get, the two numbers that we multiply would be 3 and 2. But then we're going to divide by the 3, the leading coefficient, and simplify. So one of our factors would be y plus 1, but the other one would be 3y plus 2. So 3y plus 2. Okay, so again, the denominator becomes the coefficient, and then the numerator is the constant. Okay? All right, and again, with all of these, the first thing we do is factor out the greatest common factor or a leading negative, okay? And so far, all of our examples, we haven't had any greatest common factors. If I look at 2, 7, and 3, okay, 1 is the greatest common factor. So we're actually going to do it like this. We've got a 6 and a 7. We can multiply 6 times 1 and then divide by the leading coefficient. We get 3. So this becomes w plus 3. And then that's going to be times 2w plus 1. Okay, and that's going to be our factored form right there. Okay, so I want you guys to try some. So why don't you try up to number 14. Try 12 and 13. So pause the video, and then I'll do 14 because 14 is an example that has the greatest common factor. So pause it. Now you can come back. You should have gotten for number 12, y minus 2. And 6y minus 1. And the full key is actually out on student view. All right, 13. 13, you should have an answer of 3p minus 1 times p plus 4. Those are your factors. Okay, 14. So the first thing we're going to do, if you noticed, we've got a 6, a 15, and a negative 9. We want to factor out a 3 first because 3 is the greatest common factor. So when we do that, we've got 3 times 2m squared plus 5m, okay, minus 3. Now when we do our x, we're actually only going to use the values that are inside the parentheses. So this would become 2 times negative 3 is going to be a negative 6. And then we have our middle term, which is a 5. Okay, so then we're going to think of our two numbers, which would be 6 and, let's see, a negative 1 would multiply to be negative 6 and then add up to 5. Now the leading coefficient here would be a 2. Okay, so in this example, our a, let's just specify this so you're not confused. Our a is actually the 2, our b is the 5, and the c is the negative 3. Okay, so we're not using the original a, b, and c. We want to factor out the 3 first and then find the two factors of what's left. So when we do that, that simplifies to be a 3. So our fully factored form, we don't want to forget about the 3 we already factored out, would be 3 times m plus 3. And then we're going to take this 2, this is going to be a 2m minus 1. Okay. So we're going to pause the video here. You guys can try some. I'm just going to give you the answers for time here. If you did 15, you should have found that that was prime. Okay, 16, you should have factored out a 2, gotten y plus 3 times 2y plus 1. Okay, number 17, you should have factored out a negative, and then you would have had b plus 6 and b plus 8. And then number 18, the final answer should have been, after you factored out a 2, 2 times x minus 5 times 3x plus 2. Okay, thank you, and check the key out on Student View.